Good day everyone, this is FireFlow Studio. Today I'm going to show you a walkthrough on how to set up the model, simulate it and post-process it and export it. This is a brand new FDS modeling software and it provides some great features to enhance workflow and just increase your efficiency. Let me run you through it before I speak too much. But let's start with importing a PDF floor plan so we can trace over it. I'm just going to go to my demo folder. I'm going to choose a drawing that I really set up and I'm going to import page 5. I'm then going to choose trace over the drawing rather than extrude the walls automatically. I'm going to say the scale is 1 to 50 and there we have it. If I then go to the top, my favorite or where I like to start is just to start with the floor. My snap grid is at 0.1. I'm going to use a 0.1 mesh so I know that everything is going to line up perfectly. So now I'm going to set the floor at 0.1 thickness, same as my mesh, and generate. There we have it. So now I can trace over this with my walls using the same process. Now what you will notice is if I press up, it'll align it internally. If I press down, it's centrally aligned, and if I press down again, it's externally aligned. So let's align it internally and complete the line. Let's put a height of 2.7 meters, thickness of 0.1 and create. Now I've got a 3D model just like that. So let's switch off the plan. Now if I want to create or copy up the floor, I'll just go copy a single instance, copy it up 2.7 meters, check that it's the right plane and say okay. There we have it. So one great feature about FireFlow Studio is you always have an X-ray function. So you don't have to set transparency of obstructions manually. You can always adjust it via the X-ray function. That's within the modeling environment as well as the results environment. So next up, that's a section box. You can move the section box around using shift and drag. You can change it using the toggles. You can reset it. And that's pretty much in every view as well. So if we then go to the top view and I want to include a fire, I'm just going to draw a couch over there for my living room. I'm going to call it couch, and there we have it. So there's a few ways to input a design fire. You can use the fire builder, which is quite cool, but I'll go over that in another video. But the manual way is just to put in a reaction. So I've chosen polyurethane to then create a surface. So you can go up here and add it over here, or you can simply go here and say new surface. So a cool feature is that you can just set a fire growth curve. You can define one. It can be cyclical or a single growth decay curve. So let's hold it at its peak of 3 megawatt for 100 seconds, decay it over 3 hours. And there you have it. So there it says that we need an HRPUA. So I'm going to choose 1000 and I'm going to call it burner. You can set the color manually. It is red by default once it's meshed. So if I then, let's do the mesh. So if I take the mesh tool over here, I'm just going to roughly draw it around there. I'm going to make sure that I've got a height of 2.7. Just make sure that my mesh is consistent in each direction. And I'm going to say okay. If I do the same over here, my snap grid is still set to the same, so I know that my mesh grids are lining up. And there we go. So let's just make sure that, again, it defaults to a standard. Let's set it, and there we go. So there is my meshed geometry. We can click it there, and that shows you the meshed geometry, and undo. We have yet to actually set the burner surface equal to the Z max face of the couch. So let's go over here, we go per face. It shows the last created surface. So let's just toggle those down using the scroll button, and let's just use the top one as the burner. Okay, so now we are able to put in a device. We can add it right from here. I'm just going to say, let's put in a thermocouple. Let's go down to thermocouple. I'm just going to guess. So let's say 22, 23. And let's see where that shows up. Okay, that is not exactly where I want it. So let's move it. So I'm going to say move. I'm going to say -2. And I'm going to say +2. And I'm going to say -2. And let's just see, that's our coordinates over there. And it's okay. So that's going to measure it. And if I then take a section box down, if I now, the next feature I want to show you is the ability to model both gas phase and solid phase within a single application, right? So all of that gets modeled within the software. It's absolutely fantastic. But to enable that, we need to set our boundary conditions as AST, adiabatic surface temperatures. We have to activate that so that we have a boundary condition to feed into our finite element model. So that's set. I'm going to say, let's choose this wall. Let's say FEA test so we can find it. And yeah, we're pretty much good to go. So we probably need an opening. So if I just go over here and I draw an opening over here, a hole, go back, there we go. Now we have a bit of ventilation. So I'm going to model that. You can basically, once you've saved it, let's say save demo 2, and let's call that demo 2. Okay, you can then run it straight from here. It's going to automatically detect, oh, you know what? I did not show you one of the best features, and that is if you choose this mesh, you can easily split that. Let's say 3 columns, 2 rows. There we go. And most crucially, open your mesh boundaries. So now, if I say run, it's going to tell me that I already have a saved files in there. Let's overwrite it. It's going to pick up how many processes I have. And again, it's good that we're going through this because there's a few things that come up. We have not actually set our model parameters. So let's just increase our model time to 900 just for demonstration purposes. And I'm going to run again. Yes, it automatically picks up 7 processes. It's going to split those automatically. It shows you in the console that it's currently running, and it shows you live metrics. So you can immediately see your HRR is growing, the thermocouple is reading, it's not blocked by something, it's not facing the wrong way. And if you had multiple devices, you'd be able to select the device and just quickly see without actually having to open a raw output file. And yeah, it's just a really powerful tool. It's a really powerful tool. So let's show you the next great feature. So if we click Live FEA, we'll be able to find our FEA test object. And I'm going to select spatial field resolution. You can also pick a few other options. And I'm just going to say start. This is going to ask you or tell you that you have not actually set the material. And it's going to default to concrete if you don't set the material. But if you set the material within your FDS to steel or whatever else you want, it will use those and adopt those thermophysical values for your FEA modeling. So let's say use default. It then creates a live FEA pane, and it shows that it's meshing the object. Now you can see that the model has meshed, and it's waiting for FDS data. So it's automatically pulling the AST values from FDS, and it imports it. So no two-stage workflow of having to export values, put it into a new or an external third-party FEA software. You can see it right here. So there we have it. It shows you the temperature through the X pane, 20 degrees on the unexposed side, rising towards the exposed side. And this is at 59 seconds into the simulation. So it's obviously still just really on the surface. And it just shows you, it gives you a way to monitor the model as you're running. So you can, it just gives you an unparalleled way to actually see how things are progressing as you model without needing to sift through raw data. And as always, there's section boxes through these elements. You can open it up like this to give you a better aspect ratio, more flexibility for reporting. And you can then put a section box onto the hotspot and actually check how it's how the heat is penetrating the element. Isn't that fantastic? So if I close that up, it's now modeled 69. So it trails the FDS and it basically runs in real time. So if I then save this, I can go to my results viewer over there, and that's all integrated over here. So again, here's my X-ray bar. I can reduce my opacity so I can see into my model, or I can use my section box over here. Now let's activate our FEA. Let's move this over. Let's activate HRP. So let's set the way that looks. So for my FEA, I'm going to choose a jet color bar. And for my HRPV, I'm just going to leave it as is. Now, if I run through this, you should be able to see the hotspot forming on the wall. Now, this isn't just an adiabatic surface temperature. This is actually the finite element model displayed within or alongside the FDS result. So we actually have both gas phase and solid phase being represented in a single result file in their actual locations, which is fantastic. It opens up a lot of possibilities for being able to just skip separate workflows and do it all in one stage. So as this then progresses, you'll be able to see how the heat flows through the solid, as well as just reviewing all of your usual FDS results. Now finally, or before I continue, I can also just show you that you can add your convective heat curve, you can add your radiation, and so on. And now for reporting, you can also do an export over here. So this is a great little feature. You can choose an animation, you basically put in whatever information you want over here. There we go. And you can, I'm just going to do the whole simulation. So I'm going to say, let's put in our logo. Okay. Now it's going to render that result and it's going to basically package it in a way that you can provide to any of your stakeholders, design teams, certifiers, authorities having jurisdiction, brigades, whatever. And it gives you a way to communicate your results effectively in a format that is available to everyone. So I'll show you what I mean by that in a second. And there we go. So if we just say, okay, this is the exported report, and it gives you a snapshot, it gives you the plotted data, it gives you an animation that actually skips through the result over the time interval that you selected, as well as the cool part where you can open this in 3D with whatever results you selected, and it will show it. And you can send this, it opens in any browser, and yeah, it just gives you an amazing way to communicate your results, because let's be honest, the communication is as important as actually getting the result in the first place. If you can't communicate them effectively, they are worthless. So here is just a really great way to send it out to people who might not need to work a model in any kind of way or software. They can open it in their browser and they can see. Thanks for watching, everyone. We really appreciate it. And there's a trial version live on our website at the moment. So get behind it, go give it a try, play with it. If you run into any trouble, it is a new software, please reach out, let us know. We would love to get your feedback. If there's something you like or don't like, give us a shout. And yeah, we really would appreciate any of your feedback. So happy modeling and enjoy.